Okay, so remember all these problems, we're starting by looking at this. We have our degrees Celsius to kelvins conversion, and then we have these three formulas that we need to sort out which of these formulas we are going to need. Okay, so determine the pressure. So again, I'm just reading through and kind of taking inventory of what I have so far. So determine the pressure change when a constant volume, so we know that volume is constant, so I'm just going to cross that out just so I don't get confused. Constant volume at 1 atmospheres is heated from 20 degrees Celsius to 30 degrees Celsius. So it looks like all we have here are pressure and temperature values. So we're going to use this formula, pressure and temperature. And since temperature is in the actual formula, that means that we have to convert both of our temperatures to kelvins. So all you do to convert these is you just add 273. So 20 degrees Celsius is equal to 293 kelvins, and 30 degrees Celsius is equal to 303 kelvins. Again, all I'm doing there is just adding 273 to both of those values. Okay, so I have P1, T1, P2, T2. And now I need to go back and figure out, according to reading comprehension, just which of these numbers matches up with the 1 atmosphere and which of these matches up with the mystery pressure. Okay, so the pressure, or the gas is at 1 atmosphere and it's heated from 293 kelvins to 303 kelvins. So that tells me that 1 atmosphere is the original pressure, and that temperature 1 is 293 kelvins. Temperature 2 is 303 kelvins, and we do not know what pressure 2 is. So now I'm just going to copy down my formula. So P1 over T1 equals P2 over T2. I'm going to cross multiply. So P1 T2 is equal to T1 P2. I want to get P2 on its own, so I'm going to divide each side by T1 to isolate P2. So P2 is equal to P1 T2 divided by T1. And now I just substitute. So I have 1 atmosphere multiplied by 303 kelvins divided by 293 kelvins. And then I can go ahead and multiply this out. So 1 times 303 is equal to 303 divided by 293. And we end up getting 1.03 atmospheres. Again, we always want to round to the 100th whenever we're doing this. Kelvins cancels out, so all that we have left is atmospheres.